graph a line. There are two pieces of information that are needed to graph a line: a starting point and a way to describe how steep the line is. To draw this line, for instance, we could have started with any of the points where our graph crosses the intersection of our grid lines. So this would be a good point to use, or maybe this one would have been a good one to use, or this one. We can find one this direction. But see how I'm picking places where our line crosses our grid lines? Any of these could have been our starting points to draw this particular graph. Other than a starting point, we also need some way to explain the way our graph goes up or down, how steep it is. And so for this particular one, we would probably want to draw attention to the fact that between any two of the points, there is an amount that we're going up. So this would be 1 that we would go up right here, and an amount we're going over, like 4. So we'd somehow communicate to who was trying to draw the line that we want to go up 1 and over 4. Usually we use the y-intercept as our starting point, and you'll see why in just a moment. Let's look at how we can graph using an equation. So if we're given an equation that has an x and a y in it, then that equation forms a line. As long as there aren't any exponents in the problem, our graph is going to form a line. Now, what we're going to want is equations where we are solved for y, because that gives us slope-intercept form. Slope-intercept form is y equals mx plus b. Now, when we're actually doing a problem, they won't all be letters. You'll have an x and a y, but the m will actually be telling us a number. That number is telling us the steepness of our line, which is also known as slope. And then there will be a number out to the side here that we're adding or subtracting. We use a b to represent that. That's not a 6. And that is telling us the y-intercept of the graph. So those two things that are in our equation, the slope and the y-intercept, are the very things that we need to be able to graph a unique line. We need a starting place, which is our y-intercept, and we need to know how much we're going up and over, which is our slope. Our slope is a fraction. It is our rise over our run, so it's telling us using the numerator how much to go up or down, and the run is telling us how much to go left or right. When we have an equation, if it's solved for y, let's say that this is our equation, y equals 5/3 x plus 3. We would begin with the point they're telling us, which is 3. That's going to go on the y-axis. It'll be our y-intercept. And so remember that our y-axis is the one that's up and down. This is y. So we'd start at 3. When we're looking at our slope, which is our rise over our run, it matters whether our slope is positive or negative. So since this is a positive 5/3, I'm allowed to do one of two things. I can think of that as going positive both directions, that I'm going to go up 5 and right 3. But I can also think about it as being negative both directions. Because if I had a -5 over a -3, these two negatives would cancel out and make a positive. So our positive fractions can be written as a positive, or it could be like there's two negatives. So if there was a point here and a point here that we were drawing out, we could also go the other direction, down 5 and left 3. And so we could make a point down here as well and connect our dots in this way. If our slope is negative, so let's try y equals -1/2 x plus 1. We're still going to begin with the plus 1 and put it on the y-axis. And then we're going to look at the -1/2 and say, well, this time our slope is negative. So one of the directions I need to go in a negative direction, so either down or to the left. Not both. Remember, if both of these have a negative, that makes a positive. So we're thinking of it like either the top is negative or the bottom is negative, but we don't want the top and the bottom to be negative. So if this is our starting point at 1, we could go down 1 and right 2, or we could go up 1 and left 2 and make our points. And that's going to give us a negative slope. If you look, a positive slope over here goes up and to the right. A negative slope is going to go down and to the right. So let's graph a couple lines. I don't need to erase that. Let's graph a couple of lines real quick to see how this works. Let's graph y equals 2x plus 5. Now, 2 is not a fraction, but we can fix that by making it over 1. If you ever need a fraction and don't have one, you just put the number over 1. I'm going to begin with my y-intercept, which is the number that's being added or subtracted out to the side. So I draw my point at 5. Then I'm going to use my slope, which is 2 over 1. I'm going to rise 2, and I'm going to run 1. It's a positive slope, so I want to do that both positive ways, so up 2 and right 1. I can keep going and make lots of points. I can go the other way, down 2 and left 1, and make some more points. The more points you have, the easier it is to draw your line fairly straight. Most teachers want you to at least have 3 points. Some might want you to have more. But having at least 3 points helps us be able to see exactly what our line should look like. So that's y equals 2x plus 5. Let's try one with a negative slope. What if we have y equals negative 5 over 2x, and let's do a negative y-intercept also. Let's do negative 10. So we always put our y-intercept on the y-axis, which is our up and down axis. So I'm going to go down to negative 10 and put a dot for my y-intercept. My slope is negative 5/2, so I'm going to rise 5 and run 2, but one of those needs to be negative. So if I put it with the top, if I think about rising negative 5, well, that means I'm going down 5, which I don't actually have room for. So instead, I'm going to think about the negative like it's on the bottom. I'm going to go up 5 to here, and I'm going to go left 2. And what can be really, really helpful is just take a moment now and check to see if negative slopes in general are supposed to go down and to the right. Did we correctly draw the slope? Because if I had made a mistake and drawn this way, that line does not go down and to the right like I want it to. So I would, if I check, I would know that I mixed it up. So what I want to do is go up and to the left. Oh, pretend that didn't happen there. That is the idea of graphing lines using slope-intercept form.